in the first section, even if you're not done the first section, I'm really hoping you can do at least 2 terms times 2 terms. I think for most of you, drawing an area model is going to be the best way to visualize what the product of these is going to be, what the answer is going to be. First thing to understand is, I don't know why they use the word expand to mean multiply, but you have this binomial times this binomial. In grade 10 math, you're learning to multiply something with more than 1 terms. That has 2 terms. And that has 2 terms. You're learning to multiply things that have more than 1 term times something else that has more than 1 term. Grade 9, you did 1 term, right? You did a monomial times a polynomial. Grade 9, monomial times polynomial. Here you're doing polynomial, you got to have it in brackets, times another polynomial. Okay? So that's what we have here. Here's the simplest kind of polynomial. It's just 2 terms times 2 terms. If you're doing something with 2 terms times 2 terms, again, I think the area model is the best. If you were going to visualize an area model for this, I would just think of, if you have your rectangle here, and you have, if you put one of the polynomials down the side here, and you put the other polynomial over here, it's easy to see that you're going to have 4 pieces to the answer. Whether you're writing it in there or not, you can write it inside here. X times x is x squared. X times 3 is 3x. X times 11 is negative 11x. And 3 times that is negative 33. Okay? It's exactly what you did when you learned to multiply 23 times 17. Right? You did it by saying this times this, and then this times this, and then this times this, and then this times this. That's exactly what you did when you learned to multiply 2-digit number by 2-digit number. You can combine a couple of these things. You could write the answer as just what you have there, x squared minus 11x plus 3x minus 33. It's important you keep track of the signs. But these middle two here, these two can be combined because they're the same type of term. They're like terms. Okay? So the same thing down here, right? These 2 terms, you can combine them together, and you got to look at the signs on them. One's negative, one's positive. If you have negative 11 and plus 3, you're going to have negative 8x minus 33. This is as simple as you can make the answer. This is an answer too, but it's just not as simple as it could be. All right? If you want, you don't have to use the area model. If you can just see it's this times each of the other terms, and then this times each of the other terms, that's fine too, as long as you write it in an organized way. I would say the best way to write it is, if you're doing that, do the lines one at a time here. X times x is x squared. X times negative 11 is negative 11x. And then if you write down the other term here, plus 3 times x, I would put it right underneath the other x term because then they line up, and then plus 3 times negative 11, negative 33. The reason that's good is because then the ones that go together, those 2 like terms are lined up. Instead of just writing it as a big long line, you got x squared minus 8x minus 33. When you add and subtract and work with numbers, you line up the numbers with the places that match, the 10s, the 1s. So it makes sense here as well. The x terms line up. Okay? Second one is not much more complicated other than it has coefficients in that. Now that's suddenly another question 1. That's supposed to be 2, but that's okay. 2. I changed the number when I expanded it. If you try to come up with a solution for that thing, again, I would say either visualize an area model or actually write one down. You got to put one of the things here, 2m and minus 5. You got to put the other one here, 3m and minus 1. I know it's hard to think of an area where one of the, part of one of the dimensions is minus 5, but it still works, okay? Even though in real life it's hard to have a length of minus 5. 2m times 3m, 6m squared. 2m times minus 1, minus 2m. 3m times minus 5. 3m times minus 5, minus 15m. And then negative 1 times negative 5 is plus 5, right? Again, you can have, the way this one is set up, these two terms are going to be the like terms that you can combine together. And you can write it as 6m squared minus 17m plus 5. You should double check that the signs make sense, right? The last term, plus 5, comes from multiplying those two last terms. The first term here comes from multiplying the first two terms. Right? So just kind of look back and make sure it works. The middle term is going to come from multiplying those two pairs. So you can think about whether that works as you go, right? You don't have to do the area model again. You can do it the other way, right? Just do the lines. 6m squared minus 2m minus 15m plus 5. And then add it together. You get exactly the same thing. Okay, you get that? It's a little bit harder when you have 3 terms here, but not much. The concept's exactly the same. Okay, concept's exactly the same. If you're doing an area model here, you're going to have more areas to work with, right? If you put x and a minus 2 here, and you put x squared plus 3x minus 4 here, you're going to have 6 spaces in your answer here. This is x cubed, right? X squared times x is x cubed. X squared is just like x, and if you put another x, you got 3 of them there, right? X cubed. I would do it in an organized way. This x times that plus 3 is plus 3x squared. And then you got the last one in that row, x times minus 4, minus 4x. And then the bottom row, right? You got the minus 2 times each of them. Minus 2 times that, minus 2x squared. And minus 2 times that, minus 6x. And then minus 2 times that, plus 8. The ones you can combine together, you can combine these two because they're both x squared terms. And you can combine these two because they're both x terms. If you are writing down what this is here, you got x cubed plus x squared. You can put 1x squared if you really want to, but most of the time you don't put a 1, right? Plus 3 minus 2 of them. You got plus 1 of them, but you can just write plus x squared. And then you got these two. So you got minus 10x, and then you got plus 8. If you're doing it with drawing sort of the lines, the rainbow lines here, you can do each of those. You're going to get exactly the same terms. X cubed plus 3x squared minus 4x. And then if you're doing these ones, 1, 2, 3, write those terms underneath, but line them up. Minus 2x squared minus 6x plus 8. Because then you can add the ones that go, right? It's a lot easier to add them together after. Last one here, some of you I know had trouble with it because it looked different. It's exactly the same concept. 3 terms here, 3 terms here. How many terms am I going to have? How many spaces am I going to have in my box here if I'm doing an area model? I'm going to have 9, right? A, B, and C here. A and minus B and C. You got to put that, this minus goes with the B, right? The term, the sign in front of the term matters. So you're going to have 9 terms in your answer here. So you're going to have A times A is A squared. A times minus B minus AB, right? If they're different. And A times C is AC. A times B, I would put them always with the first letter first. You can put BA, but it's better if you put AB because then we can see that these two match up with each other. They're like terms you can add together. And then we got here minus B squared. And we have BC here. And then down here we have AC. And you have minus BC here. And you have C squared at the bottom. These ones also match up with each other. And these ones match up. Okay, there's going to be lots of patterns to it if you can see some patterns. Some of them are going to cancel each other out. I'm going to start by writing down A squared. I'm also going to write down B squared. It doesn't matter what order you put them in here. These two plus AB and minus AB, they're going to cancel out. AB minus AB is nothing. Those disappear. You don't even have any AB terms. Whereas AC plus another AC, I'm going to have plus 2AC. Then I'm going to put down this minus b squared. Okay? And then I'm going to put down this and say, I have bc and a negative bc. Those cancel out as well. And then I have c squared. This is what it is. That's what it is in its simplified form. Okay, believe it or not. If you were doing it with rainbow lines, with these lines here, you can go a times a is a squared, because some people I know prefer that. A times minus b is minus ab, and a times c is plus ac. We'll do another color here. For the b's, we're going to go b times a is plus ab. I'm going to put it there because I want it to work. I'm going to try and line it up with the other one here, right? We're going to have lots of terms that don't match up with each other, right? We have b times minus b squared. That doesn't match any of the terms, so I'm going to put it over here, minus b squared. And I'm going to move this because I'm going to run out of room very soon here. Actually, we'll shrink it. We won't move it. And this is why you should all have them, exactly. Don't tell me. Plus BC there. And then we're going to use another color. We are going to use brown, because brown's such a nice color. And we're going to go C times A is plus AC. I'm going to put that one underneath here because it matches that one. And then I'm going to put minus BC here, minus BC. And then I'm going to put that plus C squared is going to be over here. If you want to write it in a big long line, you can. I did it that way because I want to see that these match up with each other, and they're actually opposites. Plus AB minus AB, those cancel out. Plus BC minus BC, those cancel out. So all I have here is, if I figure out what I have left, that, and I got plus 2 of these, minus B squared plus C squared. Either way you do it, that's the same answer. Okay?